Welcome to this video lesson on patterns and relations, where we will explore different ways of representing a pattern, including drawing the graph of a pattern. Our learning goals for this lesson are: I can represent a pattern in different ways, and I can use pictures, tables, and graphs to represent patterns. And our language goals for this lesson: I can describe patterns using words like increasing, decreasing, tables, graphs, coordinates, and ordered pairs. All right, let's look at how we can represent a pattern in a couple of different ways. Here's an example of a pattern represented with integer tiles. What is the pattern rule for this pattern? Take a second and think about it. You can pause the video if you need a little bit of time. Did you get start at 3, add 2 each time? If you did, give yourself a big pat on the back. That is the correct rule to describe this pattern. Let's look at a slightly different pattern this time. Here's an example of a pattern represented in a different way. This time we shaded in squares on graph paper to represent the pattern. So, what's the pattern rule for this pattern? Take a second and think about it. And again, you can pause the video if you need a little bit more time. Did you get start at 3, add 2 each time? If you did, another big pat on the back, because you worked out the pattern rule for this one as well. So what do you notice about these patterns? And here's a hint. Look at the pattern rule for both of the patterns. Did you notice that even though the pictures are very different, the pattern rule is the same? Start at 3 and add 2 each time. So that's an interesting thing to understand about different ways of representing patterns. The picture may look different, but it may be representing the same exact pattern rule. All right, so in this case, our pattern rule for both of these pictures is start at 3, add 2 each time. And now we can build a table of values based on this pattern. In the table of values, the input column is the figure number, and the output column is the number of squares in each figure. Okay, have a look. So let's take figure number 3, for example. If we look at figure 3 with our integer tiles and figure 3 with our graph paper, we would expect that both of them have 7 tiles. So let's count. 1, 2, 3, 4, 5, 6, 7 in the pattern made with the integer tiles. So that checks out. And let's look at our graph paper pattern. 1, 2, 3, 4, 5, 6, 7. That also checks out. So indeed, this table of values does represent both patterns. Okay, now it's your turn to practice. First thing I want you to do is extend the table of values to the 7th figure. So our current table of values goes to the 5th figure, and I want you to extend it to the 7th figure, so figure number 7. And then I want you to answer, what will the output or number of tiles be for the 7th figure? Take a moment to do that, write it down on a piece of paper so we can check it. Okay, time to check your work. Did you predict the number of tiles in the 7th figure correctly? Think about what strategy you use to extend the table. Now, one way that we can do it is to remember the pattern rule for the number of tiles, which was start at 3, add 2 each time. So we can add 2 to 11. 11 plus 2 equals 13. Then add 2 to 13. 13 plus 2 equals 15. That gives us 15, and that is our output for the 7th figure. So we can simply extend the table by extending that pattern for 2 more steps. Our pattern for the input table is start at 1, add 1 each time. So we just went from 5 to 6, from 6 to 7. And for the output, or the number of tiles, it was add 2 each time. So we went from 11 to 13 and 13 to 15. So that is one way of doing it. Now, we could also figure out the pattern rule that relates the input to the output. We see that the output increases by 2 each time. 3, 5, 7, 9, 11, 13, 15. That's skip counting by 2. That means the output increased by 2 each time. And that gives us a clue that we can multiply by 2 to find the pattern rule that relates the input to the output, or the pattern rule that relates the figure number to the number of tiles. So let's try that with input number 1. If we do that here with input 1, 1 times 2 equals 2, but that's not our output. We need 3. So that tells us that we have a second step to relate our figure number to our number of tiles. So then we have to figure out, what do we need to do to go from our current output, which is 2, to the desired output, which is 3. And to do that, we find the difference. So 3 minus 2 equals 1. That tells us we need to add 1 to the figure number after it has been multiplied by 2. So 2 plus 1 equals 3. That works here. And then we need to try it by with some of the other outputs to make sure that we're right? We can't just go ahead and say multiply the input by 2, then add 1 is for sure the rule that relates the figure number to the number of tiles. We have to try it on some of the other figure numbers and make sure that it works. So let's take this number 3 here, input number 3. If we do 3 times 2, we get 6. And if we add 1 to that, we get 7. And we know that our expected output for the input of 3 is 7. So it seems to work. Equally, if we try it with 4, 4 times 2 is 8, plus 1 equals 9. So now we can be reasonably sure that our pattern rule that relates the figure number to the number of tiles is indeed multiply the input by 2, then add 1. And now we just plug in our figure number of 7, multiply by 2, add 1, and we get the number of tiles, or the output of 15. So that's a shortcut that we can follow, and that's especially helpful if we have a big gap between where our table currently is and where we want it to be. In this case, we were already at 5, so extending it wasn't too much work. But if we had to predict, say, the 20th figure, extending the table is going to be quite a bit of work. Whereas if we just determine the pattern rule, then we can apply any input and automatically predict what the output would be. Okay, now let's learn how to draw the graph of a pattern. So let's include a column for ordered pairs in our table. Here we go. And you might ask, how do you know what order to put the ordered pairs in? And we're always going to put the figure number, or our input, as the first number in the ordered pair, and our number of tiles, or output, as the second number in the ordered pair. So when we make a table of values, our input always represents the first value in our ordered pair, and our output always represents the second value in our ordered pair. Or you could think about it as the input representing the x-axis value and the output representing the y-axis value. And then what we have after we have both numbers mapped from our figure number and our number of tiles, we have an ordered pair, and that is our coordinates. All right, so drawing the graph of a pattern, now that we have the table of values with the ordered pairs ready to go, the first thing we have to do is draw and label a coordinate grid. Now, I want you to notice that on my x-axis, or my horizontal axis, I have my figure number. That's what I'm labeling there. So that is my input column that goes on the x-axis label. Okay, so let's remember that. Our input goes on the x-axis, and then number of tiles is my value for the output. So the output column is always going to be the label for our y-axis. Alrighty. So for this table, which has figure number as our input and number of tiles as our output, we label our horizontal axis figure number and our vertical axis number of tiles. Now you may notice that I actually made a 10 by 11 grid this time. And I want you to take a second and think, why did I do that? And if you need a hint, go back and look at that table of values and see what the ordered pairs are, and think about what those ordered pairs represent. And I think you'll come to the realization that the first value in each ordered pair is our x-axis, and none of our numbers went past 10. But in our table of values, the output value, which is our y-axis value, we did have one ordered pair that went up to 11. So I need to make sure that I have a grid that's big enough that I have my space for all of my coordinates. All right, step number 2, after we've labeled the axes with the column headings, is to plot all of the ordered pairs on the grid. So we're going to mark points at 1, 3, 2, 5, 3, 7, 4, 9, and 5, 11. And here's what that looks like. So you can see we sort of have our points moving in a bit of a straight line right on our graph there. Now we don't join the points together. We will talk about why not later on this year. But what I want you to notice is every time we move 1 to the right, we move 2 up to get to the next point. So we started at point 1, 3, and then to move to our ordered pair for figure number 2, we move 1 unit right and 2 units up. And take a moment right now to think about our different pattern rules that we had for our input and our output, and think about how these might relate to the way our points move relative to each other when we graph this pattern. Okay, now it's your turn to apply what you've learned about drawing the graph of a pattern. Here's a pattern represented with counters. Your job is to record this pattern in a table and then draw a graph to represent the pattern. Finally, take a clear and close picture of your table and graph, then attach the picture to this assignment in Google Classroom and turn it in. Good luck, and make sure to ask me for help if you need it.